Have you ever wondered how big the Earth really is? In this video, FE Core will guide you through a thought process to show how a simple idea of a measurement developed into a discovery that shakes the foundation of our current scientific understanding based on the WGS-84 map system, which is the accepted model for Earth's shape and surface. You may want to brace yourself. The curvature. Earth is said to be a sphere with a circumference of 25,000 miles or 40,000 kilometers. Therefore, it has to have a curvature of about 8 inches per mile squared. Can we observe or verify this? We are taught about the ancient observations like a sailing boat going over the horizon and the measurements of Eratosthenes. They are all falsified by our current observations and better understanding of the optical effects of the atmosphere. But how can we really measure the curvature of the Earth in the 21st century? FE Core has established the Terrestrial Laser Targeting Method, or TLT method for short, to measure the geopotential surface of the Earth. Geopotential means the shape that the ocean surface takes under the influence of gravity. With the TLT method, you can accurately verify or falsify the curved surface defined by the WGS-84 geoid model on large bodies of water.
Factors in measuring the geoid model. Let's take a minute to demonstrate the factors in measuring the geoid model. How much should be hidden from our sight by the calculated convexity of a body of water?
The geoid model, or WGS-84 mathematical construct, states the Earth is an oblate spheroid 24,900 miles or 40,075 kilometers in circumference at the equator, and 24,860 miles or 40,008 kilometers circumference over the poles. If this is accurate, then given these parameters, the surface of the body of water must have an average convexity roughly equal to 8 inches per mile squared in all directions. This means in 1 mile, the surface on average will be 8 inches lower compared to the starting point. But in 2 miles, the convex surface must be calculated as 8 inches times 2 miles squared, which is 8 times 4 or 32 inches. At 3 miles away, there must be a 72-inch drop, and in 10 miles, a drop of 66.6 feet or 800 inches. In metric units, a 5-kilometer distance should create a 2-meter drop, and a 10-kilometer distance, a 7.84-meter drop. This calculation would give a result of 1,525 feet or 465 meters on the total distance of 48 miles, which is 77 kilometers, over Lake Balaton.
The polar and equatorial circumference differential is relatively insignificant to factor in, but FE Core did calculate the ellipsoid correction for each measurement. This correction value in the magnitude of 1/25th of an inch, or 1 millimeter, is well below the margin of error for the TLT measurement method. The WGS-84 geoid is not a perfect ellipsoid geopotential surface, and it may have local anomalies. Deviation from the perfect ellipsoid surface is called geoid undulation. The WGS-84 geoid undulation map shows these correction values, so this data can be compared with laser and target positions. When we stand by a lake or the ocean in the curved surface model, the height of our eye level above the surface of the water determines just how far we can see before the convex shape of the water would begin hiding objects from our view. The point where our line of sight would be blocked by the water is called the horizon, so the distance to the horizon would be determined by the height of our eyes or camera above the surface of the water.
The salad. FE Core decided to continue the curvature tests at Lake Balaton, but with a more ambitious goal of pointing the laser across a longer portion of the lake. This would attempt to measure the convexity of the lake over 41 miles or 67 kilometers. The previous tests by Sandor had been conducted in the summer and showed some refraction anomalies. Therefore, it was decided to perform the measurements in winter conditions over a frozen lake to minimize the optical density differences along the path of the laser beam. According to the plan, the observation team would keep contact with the laser position as they walked across the ice while taking laser height measurements at the previously planned positions. The first objective for the Balaton test was to design and build a laser aiming device which could make a 41-mile, 67-kilometer observation possible. Mike, FE Corps' president, took the assignment. He designed and built a laser mount capable of extremely fine adjustments for both the tilt, which is the vertical motion, and for panning, the horizontal motion. The result was the Super Accurate Laser Aiming Device, or SALAD for short. The instrument had an accuracy of 54 millionths of a degree in the tilt angle and 34 millionths of a degree in its panning motion. This was accomplished with two high-tech stepper motors capable of making movements as small as 1/10,000th of a rotation. That is equal to 36 1,000th of a degree. This rotation movement was transferred to a bolt with fine threads 1.5 millimeters apart. That meant the rail where the laser was attached could be moved in steps of 15 100ths of a micron. That is less than 1/1000th the thickness of the thinnest human hair. Measurement 1. On February 22, 2018, at 10:44 p.m.,
on the first day, we had a successful observation, but we became aware of it only after analyzing the recorded footage. My camera at the garden of the hotel recorded the handheld blue laser pointer used by the observation team as they were giving targeting signals from the opposite shore 12 kilometers away.
The blue laser pointer was 1.5 meters, or 4.92 feet, above the surface of the water. Karen's camera was 1.6 meters, or 5.25 feet, above the surface of the water at a distance of 12 kilometers, or 7.46 miles. The 12-kilometer distance calculation based upon the WGS-84 model results in a target hidden height of 4.56 meters, or 14.96 feet. The lake temperature was 2 degrees Celsius and the air temperature above the lake was 3 degrees Celsius. The ambient conditions showed the refractive indexes were about the same at the two sides of the lake where the teams were positioned. The difference in temperature was marginal both vertically and between the two sides of the measurement. The difference in humidity and temperature between the height of the laser and the height of the camera was insignificant. Measurement 3, Lake Isle, Target 1. On April 8, 2018, at 1 o'clock a.m., the blue laser was on the SALAD at 2.85 meters, or 9.35 feet, above the lake's surface. It was seen at the Target 1 position, 21.26 kilometers, or 13.21 miles, at a height of 1.2 meters, or 3.94 feet, above the lake's surface. It took less than 60 seconds for them to see the source of the laser at the Target 1 location.
Can you guys see it?
Yeah, I see it. Yep, it's there. Okay, yeah, we can see it really well there.
Can you see the reflection on the water?
I'm gonna zoom out.
Yes, we do. Yes, we do. Look at that.
Wow.
Oh, man, that is irrefutable.
Yeah.
Awesome.
I can watch this all day, you know.
This is awesome.
Yeah, this is really awesome.
Look at that reflection. That reflection absolutely caps it.
Yeah.
Yeah, that caps it. That annihilates any possibility of it being refracted, and that also annihilates any possibility of any convexity.
Yeah.
I mean, you cannot track it with being curved.
The 21.26 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height for Measurement 3 Isle Lake, Target 1 location of 18.18 meters, or 59.6 feet. The camera height was 1.2 meters. The WGS-84 geoid model differed by 16.98 meters in this measurement, which meant 93% of the target hidden height was visible. The lake temperature was 7.6 degrees Celsius or 45.7 degrees Fahrenheit, and the air temperature was 10.8 degrees Celsius or 46.4 degrees Fahrenheit above the lake. The ambient conditions showed the refractive indexes were about the same on both sides of the lake. Measurement 4. After the measurement at Target 1, Mike and Patrick drove 30 minutes to the Target 2 location. Target 2 was selected because it would be within 17.5 degrees panning limit of the salad. Since the salad had been calibrated at Target 1, the automatic GPS system now required only a new coordinate to automatically target that position. This was the first field test of the new GPS TLT software, so it was an exciting moment. On April 8, 2018 at 3 o'clock a.m., the blue laser on the salad was 2.85 meters or 9.35 feet above the lake surface. It was seen at the Target 2 position 28.68 kilometers or 17.82 miles away at a height of 0.85 meters or 2.79 feet above the lake surface.
Okay, check this out, brothers and sisters. 28 kilometers in your face.
Wow. Awesome.
That is awesome.
My camera is 85 centimeters above sea level.
Look at that. That's amazing. You can see it reflecting off the lake water.
Yeah.
That's astounding.
That's the nail in the coffin.
Yes, it is.
Oh, this is so great, boss. It's really awesome.
The 28.68 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height for measurement 4 ISIL Lake Target 2 location of 40.21 meters or 131.9 feet. The WGS-84 mathematical construct differed by 39.36 meters in this measurement, which meant 98% of the target hidden height was visible. Measurement 6, Lake ISIL Target 4. On April 22, 2018, at 2:19 a.m., the blue laser was on the salad at a height of 2.92 meters or 9.58 feet above the lake surface. It was seen from the Target 4 position 40.14 kilometers or 24.94 miles away at a height of 1.5 meters or 4.92 feet above the lake surface. The 40.14 kilometer calculations based upon the WGS-84 geoid model resulted in a target hidden height of 90.81 meters or 297.33 feet for measurement 6 Lake ISIL Target 4 location. The WGS-84 mathematical construct differed by 89.31 meters in this measurement, which meant 98% of the target hidden height was visible.
Yesterday we had a little bit of bad luck because the beam of the light was not so good visible with the camera. We could definitely see it with the naked eye, but to catch it on camera it was really difficult. So we have adjusted some things for today and we are truly expecting better results.
Yeah, but the intensity is going down.
Yeah, that's a little way down.
Okay, just put it one step up, Sandra. Okay, one more. Put the steps.
Wow!
Put the steps on.
I think I just caught that.
250,000. One more. One more. Okay. Yeah, one more. That's
Maybe
it,
one
bro.
more. Maybe.
Yeah,
I can
one
see
more.
it.
One more. You got it?
I could tell. I was looking right at it. More down.
Down?
Yep.
It's going up.
Get one now. See what's up.
I think we're looking at it.
Yeah.
April 22nd, 2018, at 11:20 p.m., the blue laser was on the salad at 2.92 meters or 9.58 feet above the lake surface. It was seen at the target 4 position 40.14 kilometers or 24.94 miles away at a height of 1.5 meters or 4.92 feet above the lake surface. The parameters and outcome of measurement 7 was the same as the one from the previous night. The only difference was the maximum refraction of 0.133 millimeters caused by the slightly different ambient conditions. The observers should not have seen the laser at any height below 89.3 meters or 293 feet, but the beam was recorded from a height of 1.5 meters or 4.92 feet.
Stop. Okay. Bring it down now. The laser down.
Going down.
Zach, if you want to record some of this, you can. I didn't know you were
Trying to record something. At least.
Okay, you still coming down?
Yep.
Okay, stop. Go back up a little bit.
The surfaces of Lake Balaton and Lake Aisel do not conform with the predicted convex shape of the WGS-84 mathematical construct. Through analyzing error source models of TRT measurements and corrections for the geoid surfaces, we determined that the TRT measurement results conclusively prove our hypothesis of non-convex water surfaces.